Hello, in this video we are going to talk about the use of artificial intelligence in the field of software testing, especially related to test automation. There are already some specific use cases, such as visual UI testing, where AI and machine learning is being used, but overall the use of AI is still quite limited in the field of software testing. Much of software testing is still done manually, so there is much potential for automating tasks and thus enhancing productivity. Artificial intelligence can be used for gaining new insights from data that would be difficult or impossible for humans to do manually. Overall, the field of AI has developed rapidly within the last years, and there is currently much interest in developing new practical tools and methods to be used in real-life business cases. This is why we at Gofore have also started a development project that examines the future potential of AI for the software testing industry. There was also interest in identifying new knowledge requirements for software testing professionals and spreading knowledge throughout the organization, as AI has the potential to disrupt the entire industry. Our project work so far has included a literature review and expert interviews. The literature review started from academic systematic mapping articles that summarized existing research work related to the use of artificial intelligence and machine learning in different aspects of software testing. The literature review was useful in pinpointing specific use cases for the use of machine learning, as well as identifying areas in which development work is still needed before AI solutions can be used in real-life settings. The literature review was complemented with interviews with Gofore's test automation experts. In the interviews, we discussed the current situation in various customer projects and how ideas from scientific research could potentially be applied in the future. It is helpful to clarify some differences between the terms artificial intelligence, machine learning, and intelligence rules used in automation. Artificial intelligence can be seen as a property of some machine or software system. In other words, the ability of the system to carry out tasks that humans consider smart. As such, it is a broader term than machine learning, which by contrast is a way to implement the intelligent behavior. Machine learning relies on computational algorithms that find patterns in data. Machine learning techniques can be divided into supervised, unsupervised, and reinforcement learning, which relate to different types of use cases. Software systems can also be made to perform intelligent actions automatically by programming explicit rules for the machine to follow. In fact, test automation is currently mainly rule-based. In some cases, the rules can be quite complicated, but the key difference from machine learning is that the computer does not learn by itself from new data. Distinguishing the use of machine learning from rules-based automation allows us to visualize different types of test automation applications along two axes. In the figure, advances along the horizontal axis relate to advances in the use of content of the automatic rules. Usually, the transition has been made from manual testing towards automation. However, this automation has been quite hard-coded and unflexible, hence the term brute force. When moving towards smarter rules-based automation, the automation must be able to make choices more flexibly and analyze the test results like a human manual tester is able to do. The vertical axis in the figure relates to the increased use of machine learning, which is somewhat of a different advancement than the use of intelligent rules. However, there are also some important relationships between these two advancements. First, machine learning algorithms require data in order to learn, and data generated from test automation systems are an important data source for this. This means that some level of test automation needs to already be in place before machine learning use cases can be piloted in an organization. Second, machine learning solutions are typically good for solving some narrowly defined problem. For example, supervised machine learning algorithms are useful in predicting the value of some variable when the values of several other variables are known. Even though the prediction accuracy might be good, this does not mean that the machine could predict some completely different variable, let alone perform software testing autonomously. In practice, advancing towards autonomous testing will probably require the integration of machine learning combined with the use of intelligent rules-based automation. So far, there are still no packaged machine learning testing solutions that are widely used in real business settings. So there's a need for applied research that would bridge the gap between academic research advancements and companies' needs. Actually, one of our findings was that within the broad scope of software testing use cases, academic research has been somewhat unevenly distributed and has focused more on certain use cases that were not as heavily emphasized in our expert interviews. Thank you for your interest. Stay tuned for our upcoming videos where we will discuss more about using artificial intelligence and machine learning in test automation. We will focus on aspects such as the role of data and go deeper into potential use cases.